Happy Friday morning, Ignites. We were commenting as people were walking in that, it is 9 o'clock the morning after the party, so we thought about kind of dimming the lights and talking really quietly, but then we figured most of you wouldn't stay awake, so we're not going to do that. We're here to talk about workstations, endpoints, security, all in one, and to kind of set the tone, right, the title may be confusing if you're not familiar with the tier model. So let me briefly explain how we think about the tier model and how that taxonomy helps us define the assets that we're protecting in the world of security. So the tier model, right, what we think of as tier 0 is the control layer. That's your domain admins, your enterprise admins, who has access to the identity infrastructure and therefore basically can get the skeleton key. I can unlock everything. If I want any of your digital assets, get one of those keys, I can get all of them. Tier 1, servers and services, that's where business data lives in bulk, right? Adversaries love to go after and get that because it's really easy to get, right? I can do a SQL query, dump all of the tables, and now I have all of the information that you had. Tier 2 is the endpoint, the workstation, where we actually live day to day. And for a long time, our security conversations have very much focused on, well, let's take care of tier 0, take care of your domain admins. You probably have way more controls over what's going on those endpoints, on those devices than anything else, because they are, statistically speaking, way more important. But depending upon what you do, there are certainly times when the endpoint itself is the asset that the adversary would want. And I think specifically of a couple scenarios that you may or may not be familiar with. One of them is I'm going to try and get the CFO to authorize a file transfer over to this account. Send $5 million over here, please. Right? I just need to gain control of your device to do whatever authorization is in process to do that, and now I have the money because of your ability to do that level of control. Or in scientific research, we see that quite a bit, right? I'm going to go and get a bit of your research. And we see adversaries getting quite clever. So the case of the CFO sniping, trying to get on their endpoint, we actually followed the trail of an adversary who was trying to get in. And what they had done is they'd compromised a single endpoint of someone who was in the organization. Interestingly, it wasn't even a Windows endpoint. It was an iPad. They didn't have to compromise the iPad. They just had to get on there to compromise the email, get their password, and now I have their password. And with that password, it's like, okay, I can now read your email. And most of you would think, great, could you reply to, right? But here's the sort of side effect of that. I can see the email, and what they saw is the quarterly financial report. Here's how things are going. Signed, the CFO. Here's my email address. Here's a general sense of when I'm working, when I'm responding. I have a little bit of information about that person. Excellent. IT department loves to send out notifications. Hey, here's our projects. Here's what's coming up. You'll have to do something on this date. Now we know an IT project to tie to, a name, a person the sender is coming from, and I can pair those two together and send a note to the CFO, hey, we're doing you a day early. Go ahead and click this button. And had they followed that link, they would have been led to a site that had been compromised on their behalf. Fortunately, in this case, the CFO and the IT director were personal friends, and she's like, what the heck? Why are you early? And he's like, what are you talking about? And we caught it. But that kind of thing happens. So even though we normally say, yeah, protect your domain admins, protect your enterprise admins, all that stuff still is really important, we can't just ignore the endpoint because that also matters. And we look at statistics. We shared this yesterday in the session we had on the Secure Modern Enterprise. We'll just quickly recap it. We're not doing the same number, but the endpoint is uniquely vulnerable to the main method of ingress. People send a spear phishing attack. Hey, click on this, open this attachment to do something. If we send it to 100 people, we find that 23 of them, statistically, on average, will open it. 11 of them will open it and open the attachment. And 6 of them will do that within the first 1 hour. So we don't have a lot of time. And we fit that into this model of how we see adversaries behave. And one of the things I've spoken about throughout the sessions I've given at Ignite this year is what we've been trying to do is build up some taxonomies to help us organize our thinking. And one of the ways that I currently think about what are my adversaries doing is thinking through how are they approaching getting into my organization. And we really notice primarily two tactics. One tactic, the one that we are really probably the most advanced in helping to protect and detect people trying to do this, is when you try to capture the identity infrastructure. Give me the skeleton key so I can have all of the things. It is a very noisy attack, right? So if you're trying to stay undetected, you probably don't want to do that. But despite being noisy, we still see this as the predominant means of getting there. Number one, because people are still really good at it, right? The average time to compromise at the domain level to get the skeleton key is still 24 to 48 hours, with the average time to detection being over 200 days. So I can get it most of the time and hold on to it for a long time, even though you have your best controls over there. Average red team actually gets it in under 4 hours, because if they get caught, they don't, it's not as much game over for them. It's just a game as opposed to real theft. It still happens a lot. But the one we see more and more of is when we're specifically targeting the asset itself. I'm going to do more reconnaissance. We see this definitely when we have nation states involved who will spend months and months researching what's happening, finding out who has the information. And examples that have come up have been, hey, this person has the IP that allows me to build this particular thing that helps me generate electricity. A foreign nation suddenly stopped buying this particular part, and we strongly suspect they'd just gone in and gotten the plans for how to build it and started building it themselves. So sometimes I'm going to go after that one thing. So that's what we want to talk about, is how do we really frame out defending against the person who's going after a specific person, a specific target. Now this kind of fits into the entire structure that we talked about yesterday. If you attended my session on the Secure Modern Enterprise, we laid out this taxonomy that said, hey, we've got identity, apps and data, infrastructure, and devices. This is about devices. How do we protect my endpoint device? And what I want to propose today is a roadmap for how we could go about iteratively tightening that up. And the iterative part is very, very important. When I find people saying, I'm going to have every single desktop at the highest level of security, that's when you run into challenges. It's hard to get everyone at a very, very high bar, every single scenario. When I talk to most customers and I say, hey, let's even talk about a Windows 10 deployment, they're like, all right, well, I'll need to figure out what software I have. Well, if you don't even know what you have, how can you possibly put in all possible protections or understand the threat environment? It makes a lot of sense to think of it scenario by scenario. So starting the first iteration, I look at, hey, I need to make more of my users standard users. Again, avoiding the concept of protection. I don't want to say, perfection, sorry. I don't want to say everyone has to be a standard user. That's hard, right? Who's the hardest people to make standard users? IT? Oh, actually, that's not who I would have said. I would have said developers. And I say that as a developer, we're kind of jerks about that stuff. Right? We're like, oh, well, I have to be admin for this reason. I have to be admin for that reason. Incidentally, we're taking away admin rights from our developers at Microsoft. We're finding ways for them to get their job done. The reality is nobody wants to be an admin. What they want is for nothing to ever inconvenience them. That's the root cause. If you don't inconvenience them, they're totally fine not having to do it on their own. If it just happens behind the back, like, this is fantastic. I have a little serve in here. That's amazing as long as I feel cool and important and never inconvenienced. That's what I really want. So making more of our users standard users. So the question is, how do you do that? I'm going to build out the rest of the slide. We're focused on number one. How do I do that? I think of it in 3 different phases. There are 3 things I need to accomplish if I want to have more people who are running as standard users. Number one, I need to take the applications that don't work and get them to working. Number two, if I'm going to take away their ability to install applications on their own, because in essence, I've crowdsourced application installation, and now I need to centralize it, and that I need to, over time, continue to maintain that so I don't create this uncontrollable beast, right? Then instead it's very controlled. The first one is one that I have a very strong opinion of. fixing busted applications. So for those of you who have not known me for years and years, sort of prior to really engaging very deeply in cybersecurity and helping people get more secure, what I did between 2006 and 2012 was that I owned enterprise application compatibility. So it's all about how do we get these things working. So we spent a lot of time thinking about this. My very strong preference is I'd like to get those applications fixed. I'd like to make it so that developers make them working in the first place, and I'd like to make it so that when they do it wrong, that you can go back and retroactively fix it. The thing that I really dislike are those software applications, those third-party apps that will help you by auto-elevating those applications that don't work. We'll just run them as admin. And there's a few out there. I'm not going to call any out by name, but I'm sure you've probably heard of them. And it's not like it's a bad idea, and it's not like it should never be used as a stopgap if all else has failed. But here's why I never like to start with that. Think about what you're doing from a security perspective. If you're trying to secure the desktop, that's the point. That's why you're here. And you say, all right, we're going to start everyone off as standard users. Well, people aren't actually represented in the OS. Applications are. Processes are. So what you're technically saying when you take a solution like that is, I'm going to move from a world in which every process I launch runs as administrator. We can all agree, yeah, maybe I don't want to do that. I can see where that's not logical. And you say, aha, here's my solution. Instead of everything running as local administrator, I'm only going to run my oldest and worst apps as local administrator. Have you really moved the bar that much? Oh, my good new stuff doesn't get privilege, but the old terrible stuff does? That hasn't actually moved the bar. And that's why I prefer to go in and fix the apps. So I'll do a quick recap. Right? This is some conversations that we had with a lot of folks who are from the desktop deployment side back in the Windows Vista and Windows 7 timeframe. It's a new audience for technologies that we've seen, and even folks who are engaging in that are saying, oh, that's kind of a good refresher. I haven't done that for a while. We have a lot of tools built into the operating system that you can use to mitigate applications and their need to run as local administrator. It's called AppCompat shims. The tool to manipulate that is called Compatibility Administrator, and it ships as part of the Windows ADK, or the Assessment and Deployment Kit. It's not the world's most elegant tool, I will say that. It's really started off as a testing tool for us, how we actually build our shim database within Microsoft, and we do have one. There are actually 5,619 applications that we fix as part of Windows, so you're already doing it. You're already shimming apps if you run any of these apps. Right? And no doubt lots of you are installing a lot of the really great things like 3D Jungle Train, really important business application. It's already doing it. It's built in. We built it as a test tool because we created it as XML, but it still works pretty well, and there's lots of information on that. What I want to go through is how do we leverage this existing knowledge that deployment folks did, helping us get to Win 7, to finish getting over the line as security gets more and more involved in defending endpoints. So I want to make sure that everyone has full awareness of the power of this infrastructure. So we're going to take an application which is badly broken. Now, this is an application that I wrote and that you can download off of my blog. Just search for Stock Viewer Shim Demo, and you can download it yourself if you'd like to have an application that does nothing but break. It's very useful as a training exercise, and it even comes with a lab guide. I'm going to point out some of the things that we'll need to know that are different from what's in there, because it was actually originally written for Windows Vista, so there's a few things that have changed since then. But it's going to pop up and say you must be an admin to run this application. If you say OK, it'll happen to keep on running, because again, it's designed to be a demo. So the first thing when we think about fixing applications is, all right, so I want to get this running. It's clearly checking to see whether you're an administrator. How do I solve that, right? The answer of, well, just make it an administrator seems easy. Turns out we often don't need it. Built directly into Windows itself, we're automatically fixing all kinds of non-admin bugs. Automatically. file and registry virtualization is a feature that says, hey, you're trying to write to program files? Well, you can't do that, so let me automatically redirect you to someplace else where you can write. No user intervention required. It's fixed right out of the box. You've done nothing, and the app just started working. It's part of UAC. By the way, table stakes, leave UAC turned on. That's super, super important. A, it's giving you some of those fixes. B, it's so foundational, it's so fundamental to a lot of things. If you came to my Windows 10 Security Internals talk earlier in the week, all of the features that our isolation containers are built upon are built on top of UAC. You turn UAC off, those go away, and we don't even run modern apps. So modern apps go away, right, and that's kind of a problem. Also, probably of note as well, how many test cases do you think Microsoft runs with UAC disabled? The answer is precisely 0. We have no idea what happens when you turn off UAC. Some of the things that we've come across in talking to customers who've done that are very odd. For example, in IE, if you right-click Open in New Tab, it'll open a new window instead when UAC is turned off. Who knew? Well, they found out. And we said, oh, well, you're in unsupported configuration, so I guess turn it on and it'll go back to what you want to do. We're not going to fix that, right? It's an unsupported configuration. So UAC should be turned on. So we've got this application that's checking to see if I'm an admin. It's finding that it's not, right? We don't want to make it an admin as a way of doing it because that does solve the problem. So what do we do instead? So we're going to go and start fixing the application. Apply a new fix. I'm going to call this for stock viewer. It's written by me. It's in program files, stock viewer, stockviewer.exe. And I'm going to apply a shim called force admin access. Now, force admin access has quite an unfortunate name because it sounds like, hey, I'm going to force this to be an admin. And it doesn't. The API that I'm calling here is the isUser and admin API. And it's bool isUser and admin. I'm going to actually type in the full source code of the shim that we put in for isUser and admin to give you a really good illustration. You don't have to speak code. You can kind of get it. Here's a function, is the user and admin. Here's what the source code in the shim will do. Is user and admin? Yep. So one common question we get is, well, do shims make me slower? Do shims make me faster? And the answer is it depends, right? If I call the actual API, I have to actually crack open your token, rifle through, look for an admin ACE, and if I find one, say, OK, good, go ahead and check it back. I'll check the flags first. There's quite a bit of work involved. This one is nearly instantaneous. Is user and admin? Yes. It makes it way faster. So a very positive performance impact. That's all it does. So if I say force admin access, I am going to have to make one slight modification. So this is, for anyone who's familiar with shims in the past, this is actually new. One thing we have to do is accommodate the fact that we in the Windows team fixed a bug. So inside of the shim engine, there's a concept called the global exclude list, which says, hey, never shim these binaries. And the global exclude list included the Windows directory and some specifically named binaries. The Windows directory part worked fine. The specific binaries we excluded didn't work at all. Someone fixed it, and therefore, now the excluded binaries no longer get included. Those binaries, somewhat unfortunately for this demo, happen to include the .NET framework. So if you need to shim an application that's built on .NET, you have to add in 2 modules into the include list. And I say this just for anyone who's doing any detailed work here. This is not important to the story. I just wanted to explain why I was typing these 2 things in here. This is saying, hey, this is managed code. Go ahead and fix it anyway. Now I've put together my fix. I can save it. Save it as Ignite. I'll stick it on my desktop. And then I can install it. And now it's installed locally. Now the file itself, just to kind of carry the story through to the end, is an SDB file that can be installed through a single command line from a command that is inside of the System32 directory of every installation of Windows called sdbinst. Since it's in System32, it's usually a single line of script that doesn't need a path. So it makes it really easy to do that. So just call a script that runs SDBinst, and we can deploy this en masse. I'm just doing it locally here to show the impact of fixing it. But I've said, hey, pretend to be an admin, and boom, right past that. So what normally starts out as, oh, it says it wants admin, let's give it admin. Now we've taken away that need for admin. And if we proceed, I'm not going to go through and fix every single bug, but I do want to make sure we kind of get a tour and get a sense of how much we can do. Is if we go and exercise a few options, right? So tools options, it's going to say, oh, that was a failure. And again, normally this would crash, right? I actually gave myself an out, and I can say, go ahead and continue. I'll do help, check for updates, check that out. Oh, there's another one. All right, let's go ahead and continue from that. And I'll go into trends, and it'll say, oh, I copied this, I added this line of text, but the rest of the error message I literally copied and pasted from an actual customer application. I'm like, I don't even know what I would do with that. Incidentally, oh, hold on, now we have to take an aside for this one because I think it's important to know that error messages tend to not be believable. This is the greatest error message I've ever come across. It's loading, and you see it literally filled the screen. And I had to take a picture. I'm like, that's amazing. Because you know what's actually broken about this? It's a failed version check. Are you Windows 2000? Oh, no? Well, let me dump that on the screen. If you give it a Windows 2000 version, it'll just run like a champ. So error messages are not always to be believed. Do some debugging, but this is word for word what happened. Now, as someone who's been doing app-compat-y type stuff since 2006, I could probably troubleshoot most of those visually. Most normal humans would not find all of these to be obvious. So instead, it's good to have a tool. Now, there's a tool set that came out initially back in the XP days. It was actually developed for work initially with the United States Air Force on getting them all to run as standard users, right? So as a journey story, that project was so successful that the Office of Management and Budget out of the White House in the US said, hey, if they can do it, and incidentally, they got to 500,000 users out of 650,000 seats on the first try on Windows XP, which I assure you was not a lot of fun. And this helped that the entire government then had to do it because of that success, right? As part of that transition. It's absolutely possible, and they did it without any elevation tools. This tool is still available. It's really interesting to me that it still thinks it's in the old DPI setting, so it's a massive window. It's normally not quite this large, but you just point it at the application. And what this does is it means so that you don't have to actually go in and debug everything for you. It'll troubleshoot it. The application is written by my friend Aaron Margosis, and here's the architecture when you think about how it was written. How he designed it is it takes two tokens, has them both sitting in the process, one that's elevated, one that's not. It tries everything with a non-elevated token, and if he gets a failure code, he tries the other one, the elevated one. And if the elevated one works, then he logs it as an issue, because it didn't work non-elevated, it did work elevated, so chances are statistically very, very high that it's actually an issue. There's no guessing, it just tries both. A beautiful, beautiful architecture. And it works. Right? So now, all we have to do is run the application, and it'll pick everything up for us. Tools, options, oh, yep, oops, tell me what's happened. So the app is just running. I don't get blocked at each and every individual error. Right? I go help, check for updates, and it'll go and waiting for this command. Right? And I'll click on the trends button. It'll actually open up that little table. And everything worked. When I close the application, I say, yep, I'm all done. Here's the report. Here's everything that happened. And I can see, here we go. I was trying to create this registry key. Here's the actual key name that was being used. I can get all the details if I double-click on it. That's quite helpful. And at the bottom, hey, here are some suggestions that you might want to use for for fixing it. So now it's pointing you to what you might be able to do. For writes to HKCR or HKey classes root, oh, that's exactly what it is. Try these. Or per user keys or loosen permissions as a last resort. HKey classes root, incidentally, doesn't actually exist. There's no such thing. There's no registry hive on disk at all. It is a virtual merge of HKey local machine /software/classes and HKey current user /software/classes. It just meshes them together and says, here's HKey classes root. Oddly, and I have to actually research the reason behind it. If you're trying to read from it, it'll prefer the user one. It'll read the user first and machine second. If you're trying to write to it, it'll try to write machine first and user second. Unfortunately, it doesn't capture the failure and then retry. It'll just give you the access denied and not move on. You have to explicitly ask for the per user one when creating it. The somewhat unfortunate thing, which is why I'm spending a little bit of time focusing on this one, if you have any apps that you want to fix up, is this whole HKey classes root problem. If you were to go and get a copy of Visual Studio 6, so Visual Studio 1998, or is it 98 or 97? 98, Visual Studio 98, which probably a fair number of people still have, given the popularity of maintaining VB6 code, it's probably still there. If I go to get one, and I go to build a brand new Visual C++ project, there is a single checkbox that will say, make this an ActiveX exposed executable. If you check that checkbox, we will automatically generate code for you that will violate this principle and trigger this bug for free. So consequently, since it's a single checkbox that a fair number of people clicked, there are a few of these bugs. It's good to know how to fix it. It talks about other objects like, oh, here's a file mapping object, right? So maybe we can fix that. And oh, this is error elevation required. Try the elevate create process shim. So two of them brought us right to the solution. So let's real quick just get a sense of how quickly and easy we can go through and do that. We've taken the tool. It's pointed me in that direction. I'm going to edit. So I right-click, edit the fix. I'm going to fast forward past the layers. By the way, layers are just combinations of shims, sort of pre-done. I go into the actual shims themselves, and I'm going to do virtualize HKCR Lite. I'm going to add, that's going to fix the HKey classes root problem. It's going to just redirect it to the user hive, and everything will be fine from there. I'm going to do the elevate create process that it suggested when it was creating the process. And the other one is local mapped object, right? And that's one I would probably have to do some research on. It didn't tell me in the tool, right? But nonetheless, it's part of the solution. If I save that, right-click install, and then go back and run the application again without running it elevated. What did I do wrong? It's manage code. So I forgot my includes despite elaborating on them last time. I can say show selected, and let's make sure we actually get them included. So parameters, I need to make sure I include mscorwks.dll and clr.dll. Otherwise, it is excluded as Windows binaries. Because we're really trying to reduce the surface area of what gets shimmed as much as possible. Our assumption is that Windows itself is compatible with Windows. So we tend to exclude those, because otherwise it's going to apply to everything else in the system. So we'll quickly do this. mscorwks.dll. And this is by way further emphasis that, that little quick bit of debugging we did, you can never actually have a failed demo if you've got the right attitude. You simply have unplanned debugging demos. So we'll add mscorwks and clr.dll, add those. And now save and install. And now if we launch again, now our functionality is working. And if I think about the power of that, right, I don't see a typical environment where I see people trying to look for the easy button, say make things work, right? There are two different profiles that I see. I see the profile of someone who just said, just anything that says anything at all, a little bit odd, elevate it, just throw it on there and get really large piles, right? That becomes challenging because it becomes difficult to unwind that. Most of the group policies to control those auto elevation products are basically start at rule number 1 and work numerically, sequentially through to the end rule. but the rules can be overlapping. Some of them are binary rules, some of them are path rules, some of them are hash rules, signature rules. There's all kinds of different rules, and multiple rules may apply to a single binary, and unwinding it gets hard if the numbers are big. The other ones are, hey, I just have a handful on here. If I can use these techniques to get rid of that handful, I can significantly improve my security posture. Now I'm further reducing where I have admin rights. Now I can't necessarily fix absolutely everything, and I like to be pragmatic. I start with this. I like to do this. I get that there aren't a lot of people who are experts at applying app-compat shims, but we can find them. Right? There's been a lot of people we've worked with, both within Microsoft, within partners, we've provided that training. We just need to find and get aligned with experts if we want to launch such an initiative. Because in the end, you can fix just about every non-admin bug that you can come across. There are two types of bugs that we've not yet been able to fix. One is privilege. I'm trying to enable a privilege. If you don't have it, then I can't enable it. So privileges in Windows, in essence, are... Let me actually go ahead and dump some. And I'll switch over here. Privileges in Windows are a permission for you to do something that crosses the admin-non-admin boundary. Right, so when I think about, hey, I want to shut down the computer. Primary rule of standard users is standard users can mess around with all their own stuff. Admins can mess around with everybody else's stuff. Now, the primary difference. Well, shutting down the computer clearly impacts other users because the computer is now turned off. But if you can't shut down your computer, you don't have a very useful device, right? If it's going to have to always be on because I'm not an admin, no one can ever shut it off, you're going to have some battery problems, right? So we give that as a privilege. There are other privileges in Windows, such as the SE backup privilege or the SE restore privilege. What those boil down to is if you have the backup privilege and you enable it, you can read anything you want to on the file system without an access check. If you have the restore privilege, you can write anything you want to on the file system without an access check. If you have the SE debug privilege, you can open any other process in Windows without an access check. Now, how privileges work is they start off, if they're in your process, they will start off turned off. Principle of least privilege. But a privilege that's turned off doesn't mean it can't be used, because all it takes to use that privilege is write one extra line of code, enable privilege, then do the thing. And then disable the privilege is the pattern that you're supposed to use. No barrier at all. So if you have the privilege in your token and the adversary says, well, enable the privilege and then do this thing, then now they have control over it. So we intentionally restrict the privileges that are used. So if I need to enable the backup privilege and I don't have it, there's no way for us to pretend, because most of these shims we have in there are just, hey, let's pretend about something. Yeah, go ahead and say that's true. Make something up. Give it a different answer. So I can't fix those. And there are other objects where if I'm trying to get into some other kernel mode object other than the file system, which I can redirect, the registry, which I can redirect, that there aren't all those tools. Like if I have an event, I'm trying to open an event, and the event has an ACL on it, I don't have a shim to fix that. Fortunately, pretty small surface area of what you can see. So the main message is you should be really optimistic about your ability to get more applications working as standard users to overcome that, and then you can work on the rest. How do I get my applications packaged? We had a great conversation yesterday with some customers I was talking to about developers, and how do we get developers to move as quickly as possible? And the answer is, well, a lot of them have applications that that update very frequently. If my packaging can't keep up, they're not going to accept the solution. So I need to make sure that my packaging processes can keep up. So make more standard users. The next step in the roadmap is, great, now you're a standard user. Now I can start making some promises I can cache. Because the problem if I leave them admins is, if you're still an admin, I can put all the rules I want to on your system. You're the administrator. You can turn them off. Right? One of my favorite demos of why not to make someone an admin actually happened, it was at TechEd Barcelona in 2007. Mark Rusinovich actually was doing his Case of the Unexplained, and he explained what admins can do in terms of rules being enforced. There was a policy that Microsoft IT had laid down onto his device. He was flying on a flight from Seattle to Barcelona, and he was trying to install one of the CDs from PC Gamer magazine. This is back when it used to ship with CDs. This is how long ago it was, right? Remember when downloading was really hard for game demos? Trying to install something to do something on the plane. So we needed a mental break. And one of the rules wasn't letting him install it. But he's the local administrator, so he was actually showing to the audience, here's how you can go through and turn off this rule. We'll go ahead and take this particular configuration, this policy, which maps to a registry key, change the registry key value, remove the ability for local system to modify the registry key value, and now it's locked out. Now you can't reclobber me the next time GP update runs, and I've taken control over it. So it starts with that, and then we move down the pipeline. And the next one is, all right, let's think about how do we modernize? Because the reality is today's software does a better job at defending itself, at defending you, than software from 5-10 years ago. Right? We're doing a ton of work to help protect against the security threats that exist today. Right? There are more defenses available. Back in Windows 7, we had UAC, we had integrity, right? All kinds of details on my security internals talk there. Even moving to Windows 8, we gain the benefits of app containers and further isolation between them. When we move into Windows 10, we have virtualization-based security, providing an even tighter container around it that's being used more and more frequently. And we can leverage that to further protect us, to further make us secure. Now, when we think about this, right, okay, I like this idea. It kind of makes sense. I don't know too many customers who are saying, yeah, Windows 10, I think it's kind of a fad. I think I'll wait on Windows 7 because it's so darn good and I just love it so much. Right? Eventually, I forecast there will be some customers who will kind of ride it to the end. But our hope is if we make it easy enough and we make it familiar enough and productive enough that everyone's going to be like, hey, there's no reason for me not to do this. So we think about how do we go through and do that deployment. This is actually somewhere where I would give a bit of guidance that probably differs from what you've heard so far. Because what you've heard historically has always been, hey, you can get down to one image. That's fantastic. Everything should look the same. What I would say is everything shouldn't necessarily look the same. Yes, you're going to start with your standard productivity image. But as you think through other scenarios, you may think, administration. If I'm the domain administrator, do I really want to have the same policies that are allowing email, that are allowing web browsing, that are allowing all of these potential threat vectors as I would for someone who is just a generic information worker? And I would say, no. You probably want to treat that very differently. Different policies, different controls. Looking at people who have access to unique IP. Right? The example I gave yesterday was some work we did with a credit card processing firm where there were a couple of roles that had access to the entire stream of information. Credit card number, where's the money going? Right? If you're the bad guy, the ability to modify where's the money going is really tantalizing. We want to treat that differently. We have scenarios within Microsoft we want to treat differently. There are things that we do in our Cyber Defense Operations Center where we have to look after the really dark, seedy sides of the web, which means we need to get onto workstations that are either A, honeypots, completely undefended, let's see who's going to come out and try and tag us, or B, pretty distanced from what Microsoft in general looks like so they don't know it's us, right? You don't want them to say, smells like the cops. So we have different scenarios that we implement for locking it down. Or low-trusted workstation, like kiosks. What do I want to do in a kiosk? Right? To open up, to isolate, to contain it so I don't have much damage. Right? To start thinking through what are those scenarios and how would I configure them? And is that by group policy? Is it actually in the image, in the devices, in the build process? Right? The build process, typically, historically, how do you build most devices historically? You bring them in. All right, here's my brand new laptop. Let's plug it into the network and fire it up. That's how you do it. Makes a whole lot of sense. Unless you're trying to make a hardened desktop. And you're like, well, hold on. I don't necessarily trust my wide open network that everyone can get to. I don't want to plug it in before it's hardened. Otherwise, the bad would be like, ooh, new workstation. Now I can go party on it. And now you're building on top of an untrusted core. So the process may differ as well. Now, the question of how to get there right? That's what we've been doing a lot of thinking about, is like, how do I really understand the risk? If I'm going to go, and Windows 10 is the one everyone's talking about right now, right? There's probably a whole bunch of sessions here. I know Michael Niehaus was here talking about deployment processes and Windows as a service and things like that. I focus on security and I focus on compatibility. And when we think about compatibility, the thing I say is we need to understand, how hard is this actually going to be? We need to take a risk-based approach. If the last migration you did was off of Windows XP, I get it, that really sucked. Unless you turned UAC off and left everyone as admins, in which case you're like, I don't know what the big deal is. If you did that, right, that's technical debt that we need to go back and pay, right? What we didn't do in Win 7, we just go back and do that now. So the migration to 10 is going to get harder by the amount that you deferred from there, but most people did. So when we start thinking about what the actual risk profile is, here's kind of what I did on the spectrum. Statistically speaking, to give you some numbers of what we've seen, the migration from Windows XP to Windows 7 or to Windows 8 ended up having an average of 21% of applications that required some form of touch, whether that be repackaging, whether that be app-compat shim. Sometimes they were just upgraded, they didn't care. Sometimes they got retired, but something had to be done with them. 21%, kind of a big number, right? When 1 in 5 is falling over, you start thinking, well, maybe I'm going to look at everything, because there's a fair bit of risk surface area. What we've seen so far in the migrations to Windows 10 is that if you're coming from Windows 7, it's roughly 2%, a little bit shy of it, but I'm rounding up from there. 2% of applications that have something that needs to be changed about them. If I'm coming from Windows 8 or 8.1, it's a fraction of a percent. And the difference is actually really interesting. The difference between the two is based on different behavior. This is, interestingly, not running. But let's go into Tools, Show Me a Star, right? And here's a little application that's saying, hey, that is the difference. It's hard-coded version checking. Everyone replaced their checks for Windows XP with checks for Windows 7 for reasons we can't explain. I actually sat and watched someone updating a package saying, if version NT equals 4.00, or version NT equals 5.00, or version NT equals 5.01, or version NT equals 6.00, or version NT equals 6.01, or version NT equals 6.02, or version NT equals, and he was about to write, or version NT equals 10.00, and I'm like, are you out of your mind? Do you not have a greater than key on your keyboard? Because you'd think that'd be easier, right? Number one. Or number two is, do you lack that much confidence in your IT department that you don't think that they're going to manage to get anything higher than NT 3.51 deployed? Because that's what you're checking for. Because that's really what it is. I would say don't write it. Why? If you think that they can't deploy it, talk to the executives rather than, hey, every single time you launch it, let me just double check and make sure you haven't rolled back your machine to NT4. So this is the problem. The fix historically was pretty easy, right? So if I go in and I'm going to have to actually fix a new application, star, just to show you how easy it is to get past this and get upgraded to the new version, go into stock viewer, and this is one of the most poorly named binaries I've ever done, but it is what it is. And I'm just going to pretend to be XPSP2. A version lie, and it's like, okay, great, now I'm version lying. Let's go ahead and save it, right-click and install. And now that I am version lying, when I go to Tools, Show Me a Star, amazing, I get a star. Whew, dodge that bullet. That's how easy it was. But the problem was so many people did it, we're like, all right, we need to think of some way, because even though that was pretty easy, you now all know how to do it, and every single one of you could go back and fix version lie shims. You know exactly what to do. Easy peasy. The problem is you now have to actually do it. That's an additional touch. So we came up with an idea. Rather than lying by exception, what if we just lied from the start? And that's exactly what we started doing in Windows 8.1. If you ask Windows 8.1, hey, Windows, what version are you? I'm 8.0. If you ask Windows 10, hey, what version of Windows are you? I'm 8.0. We lie by default until you put in a compatibility manifest into your application, at which point we'll start telling you the truth. So that makes it much, much easier. So I get onto the latest version, and that's why Windows 8, since that's where we started lying by default, has an even smaller rate there. But we actually know how to do these low-risk deployments. We're really good at them because we get to practice once a month. We know exactly how to do something that breaks almost nothing. We call them Windows updates, and you've got a ton of practice. We want to make the behavior we have there look a lot more like that behavior. Not completely. It's a little bit to the left, but we don't want to do what we did on XP. We need to be smarter. We need to be agile. We need to understand the application risk that we actually face, start to organize this, get really good understanding of our applications. We need to understand how many things ought to fall there. This is one of the challenges when you put this out, because if you ask your end users, hey, which of these are critical, please rate these, and completely crowdsource it, what we find is that statistically speaking, 70% of your applications are mission critical. Literally, if any single one of them failed, you'd go out of business. If that were true, that is a really risky organization you're running. What should fall in here, and how should I approach it? What's the work that I should do to test it? Anything from, hey, full end-to-end regression, which I might do for one or two absolutely essential applications, all the way down to reactive, hey, if it's broke, give us a call, which is honestly the most typical Windows Update approach that I see. Day one, put it on my machine. If I'm not complaining by the end of the day, day two, my team gets it. Day 3, the floor. Day 4, the building. Day 5, the city. Day 6, the country. Day 7, the continent. Day 8, the rest of the world. That's reactive testing. Automated testing hasn't yet proven itself to me, right? The accuracy rate really matters. This was really problematic because automated testing was super effective coming from XP. Super effective, right? We saw accuracy rate at the portfolio level of around 90%, using the Bayesian algorithm for predictive accuracy. It turns out that on a per application basis, the actual accuracy you see is about 57%. So we just wrong the remainder of the time. But it's still much more accurate than anything else we've seen. Really, really effective. When we look at what we see today, because the failure rates are so low, it's around 2 to 3%, which means it's wrong 97 to 98% of the time in what it tells you, which means it may not be worth spending a whole lot of time or money looking at that. If you got it, it's good input, but if you don't have it, I wouldn't go seek it today until I saw data that indicated. My answer to that always changes based on the data, right? So build out your testing distribution so you're doing really smart things to make that transition. You can go a lot faster and take that agile approach and start doing it in sprints, get some momentum and move along. A little anecdotal side note is that the single greatest predictor when we worked with customers of whether or not they were going to get to the project sooner than later is that we saw an average that if the people in the room running the project themselves had the new platform when we began, those projects would, on average, run 5 months more quickly than those who people in the room were so risk averse they wouldn't even run it themselves. Get momentum, and that helps going. And really helping to get to that modern platform, figuring out ways to get there quickly while still doing your due diligence and managing risk. And it's not just about Windows. It's not just about how do I get this Windows 10 so my sales guy stops poking me and saying, hey, how about deploying some Windows 10? Hey, some Windows 10 would be really great in your organization, blah, blah, blah. Don't think it's just Windows. We've also had, that's awesome. Oh, no, I went too far. Also had an announcement that maybe you noticed. Oracle says, hey, you know what? Java applets, nah, we're not going to do that anymore. Who didn't know that? So a handful of people are like, oh, shit. I have some stuff to do, right? That's a problem. I've yet to meet a customer that can tell me with a straight face that they have no single instance of Java on any desktop anywhere in the organization that's running anything other than the current version. Java is middleware, and I need to manage that middleware. So I get more standard users, I get onto a modern platform, I then need to think about how do I go about hardening it. And hardening it is one of the things where I strongly recommend that you leverage the information that we have available on how to do security baselines. So, and the reason I do that is that security baselines help you get known and proven solutions. So we'll go to the blog here that kind of talks about it. We've actually just released it for 1607. This is a security baseline that we configure in partnership and in collaboration with folks from the US federal government, representatives from other security organizations, to say this is a configuration that we can stand behind that gives the controls you need for high security implementations, but that's known and trusted, that millions of other devices are already running. So that I don't end up with some of the problems. If you notice when I first opened Notepad++, I had a few things open up here. I'll go back here, right? This is the number of different ways that you can configure just the group policies for IE. And this is the number of atoms in the observable universe. Turns out we don't have that many test cases, right? The point of baselines is let's all have the same thing. It'll be high security. So A, we don't have to spend the time determining what's secure. And B, we can all learn together. If one person knows it, everyone can learn and adapt and grow from that, right? And iterate that over time. Our goal is always to have security baselines published by the time a build is declared the current branch for business. That's the timing, right? So we've released, actually beat it by a few days this time. 1607, the policies are out. Server 2016, the policies are out. So we have that baseline and strongly recommend leveraging that to harden the image and help protect against compromise and have that consistent, known, and proven solution. Moving further down the roadmap, think about hardening the software. What are you doing in terms of a build process? This was a big change within Microsoft, is that we needed to change how we wrote software, because if I want to get into one of your organizations, you've got something I really want. There are all kinds of mechanisms of attack, including, well, let me just hack into the developer who's writing the ODBC stack and write a vulnerability, get it checked into the code in a place that no one ever looks in, oleauth32.dll, and then just wait for it to land on your machine via Windows updates and then go trigger that exploit and get your data. Sounds convoluted, right? But if you're a nation-state actor with all the time and all the brains in the world, that's a way to get into customers anywhere. Holy crap, we have to protect against that. That's important. So we look at building out the processes, and we share these processes with everyone who will listen. Our whole security development lifecycle, or SDL process, and the tools that we have, and the threat modeling. One of the things that we're piloting within Microsoft right now is sharing customer threat modeling, but sanitized information, so that we can develop that proficiency within our own organization for folks who are having conversations, not just the developers, but using threat modeling to model out the infrastructure, to model out an architecture, to model out everything, and really understand how we make that more secure. So make good, secure software, so I protect the soft underbelly. The next step is, okay, great, we've got a modern OS, we've got it hardened, we've got software that we feel pretty confident about. Obviously, it's a progression. We'll keep getting better. I'd like to next move to whitelisting. I don't want untrusted code. I want to transition from trusting code by default to trusting code by exception. That's also hard for the same reason. I don't always know what stuff I have. So one of the approaches that we've seen used within some customers, we've worked on it in conjunction with some of the big government agencies in both the United States and other countries, is rather than specifically whitelisting everything, let me just blacklist anywhere that the user could potentially write to and whitelist everything that's in a protected area, admin access only. So the Windows directory, if you can land in there, you're an admin, it's okay. The program files directory, if you can land in there, you're an admin, and that's okay. Inherent assumption, the user is not an admin. There are a few directories, and we've been working on putting together some scripts to detect these, that will be user writable that we have to also exclude. So there's little black holes in the middle of this. But this approach drives us down that path. Now it's taking away the threat vector of, hey, someone sends an exe in email, and they download it because our users are awesome at doing stuff like that, right? They don't actually do work nearly as quickly as they open attachments. Right, and now it's running. Well, it's user writable area. It doesn't run. And we've put in that layer of protection while we move towards actual whitelisting, where we're going to specify, again, scenario by scenario, what are you going to do? What are you going to allow to do this transition that says, hey, move from trusted by default to, I can't detect everything, and let trust be earned, which we can do historically with App Locker. Before that, software restriction policies. So I think that means we've renamed it every OS release. Is that right? Oh, no, we didn't rename it for Windows 8. We skipped one. But the idea is you're going to be this application. Now, historically, there's a lot of popularity of third-party tools because it got really hard to do that if you didn't have digital signatures. And that continues to be true. DeviceGuard relies on digital signatures to get its job done. DeviceGuard is hardware enforcement of that concept of whitelisting. So it's a really powerful construct to keep untrusted code from running, but it requires me to know my code, right, and know what's going to go on there and have digital signatures. Digital signatures really will continue to be key to all kinds of security initiatives, right? So I would encourage you, if you currently don't have good code signing capability, to look at investment there as having a big return on your security on the endpoint and on the server, because with Server 2016, you can also implement that code integrity on your server apps, on your domain controllers, and the rest of the tiers. Definitely something I would be investing in as we think through how do we put in these levels of protection, right? And DeviceGuard, all kinds of goodness about that and providing some additional security. Moving down the line, I've whitelisted my software. My final component is I need to think through, right? I've done a lot of talk about protection technologies. Detection's a little bit harder. I didn't go into a lot of details on detection, right? There's some, presumably there's sessions here on advanced threat protection. I just didn't have time to fit it in here, but something worth looking at in terms of detection, right? Detection, there's always a little bit of a gap because by definition, you're trusting the potentially compromised device to accurately report on its compromise, right? That's why things like ATA, which look at authentication behavior outside of the device instead of having the device be trustworthy, because if it's been popped, of course, it's going to lie. But there's still a lot of really good signals that are coming in that are helpful. So detection, important to build on that. And then response. How do I respond if I do get compromised so that, hey, if someone gets through, I've tried to block you at the front line, that I can do offline backups, that I can do things like, hey, what are the shadow copies that I have on the device that I could potentially leverage? Do I have offline backups? How far do they go back? We have seen in one attack that took place, we were actually looking at backups as restoring it, and the adversary had actually gone back and taken backups all the way back without changing the timestamps, incidentally, for over 18 months of wiping out backups. So what are my defenses? What do I need to protect? And again, this is the scenario by scenario. Who am I trying to protect? What value do they have? What assets do they have as I think through it? And then we iterate again. Here we are in our journey. We start with, hey, let's get our user standard users. Let's get everything modern. Let's get everything hardened. Let's build everything with the highest integrity. Let's get it signed. Let's get it trustworthy. Let's get that tamper resistance. Let's start running it by exception rather than by default. And let's keep thinking about how we detect any issues, any anomalies, and how we respond to that in order to build this holistic defense on the endpoint. Because just because we will say, assume breach, assume eventually someone's going to fall, one of those 6 people is going to click something, just because we know we're not always going to win, doesn't mean we should forsake the battle. Let's try and hold our perimeter. This really matters. We can make a ton of progress, and I hope you'll join me in the journey to really secure the endpoint. Thank you very much.
Looking for adventure.